Moving on to the question and answer section of pages 46 and 47 in our Forces and Motion book. The first question that we come upon has to do with figure 2. It's about Newton's second law, and it's asking our question. Suppose that 4 dogs pull a sled carrying 2 people. Explain. Use words and fill in the pictures to show how you can change the dog-person arrangement to change the sled's acceleration. How could you increase the sled's acceleration? Well, if we increase the number of dogs pulling the cart, we will increase the net force acting on our cart, and that would increase our acceleration. But another way to increase our acceleration would be to lose some people that are riding the sled. By losing people on the sled, we decrease the sled's mass, thereby making it easier for the dogs to pull the sled and increasing our acceleration. The second part of this question is, how could you decrease the sled's acceleration? Well, when decreasing our acceleration, we could decrease the number of dogs pulling the sled, thereby decreasing the net force acting on the sled. Or, if we added more people onto the sled, we would be increasing our sled's mass, thereby decreasing our sled's acceleration. Moving on to page 47 and our Do the Math section. Every year in cities around the world, teams create cars, push them across platforms, and hope they will fly. Unfortunately, the car always ends up accelerating down into the water. Calculate. If a 100 Newton net force acts on a 50 kilogram car, what will the acceleration of the car be? For this, we're going to need our acceleration equation from the previous page, where it says that acceleration equals net force divided by mass. Because of the space I have available, I have abbreviated this down to A equals F, our force, divided by M, our mass. This is a pretty easy equation, because we know that our net force is 100 newtons, and our mass is 50 kilograms. For this equation, I have changed Newton into its SI unit of kilograms times meters divided by second squared, and I have taken that divided by 50 kilograms. 100 divided by 50 is 2. Our kilograms units disappear because they're on both the top and the bottom, and I'm left with an acceleration of 2 meters per second squared, or 2 meters per second per second. The second half of this question: after that same car leaves the platform, gravity causes it to accelerate downward at a rate of 9.8 meters per second squared. What is the gravitational force on the car? We will need our second equation for this. Remember that net force equals mass times acceleration. So over here we have our net force, which I've represented by F with the word net underneath it, equals M, mass, times acceleration, A. Our mass is 50 kilograms. Our acceleration is 9.8 meters per second squared. And this turns into 490 kilograms times meter per second squared, which is also our SI unit for newtons. Kilograms times meters per second squared. So I can shorten all of this up into 490 newtons. Moving on to the Assess Your Understanding section. 1A. Review. What equation allows you to calculate the force acting on an object? Remember that our net force, F net, equals mass times acceleration. B, calculate. What is the net force on a 2-kilogram skateboard accelerating at a rate of 2 meters per second squared? All we need to do is use the equation that we just wrote down before. Our net force equals mass, 2 kilograms, times our acceleration, 2 meters per second squared. 2 times 2 equals 4, and gives us a unit of kilograms times meters per second squared, which is also equal to newtons, so our final answer is 4 newtons. C, predict. If the mass of the skateboard doubled, but the net force on it remained constant, what would happen to the acceleration of the skateboard? Well, remember our sled question on the page before? We know that acceleration would decrease as the mass of the object increased. The heavier the object is, the more difficult it is to change its velocity. The more difficult it is for that object to accelerate. I get it. Now I know that Newton's second law of motion describes the relationship between acceleration, mass, and force. Please take some time now to write down if there are any questions you have, any part of this that you would like some extra help with. Thank you.